Hey, let's move on to the second video of this section, creating 3D histograms. In the previous video we saw how to create 3D bars. We'll start by importing numpy package and then generating x and y from normal distributions. We'll then plot the scatter plot of the same dataset. In this video we'll learn how to create 3D histograms and spot correlation between three independent variables. Similarly to 3D bars, we might want to create 3D histograms. These are useful for easily spotting correlation between three independent variables. They can be used to extract information from images in which the third dimension could be the intensity of a channel in the XY space of the image under analysis. Let's now recall a few things. So, a histogram represents the number of occurrences of some value in a particular column, usually called a bin. A 3D histogram then represents the number of occurrences in a grid. The grid is rectangular over two variables represented by the data in the two columns. For this computation we first use numpy's help, as it has a function for computing the histogram of two variables. Then we generate x and y from normal distributions, but with different parameters, to be able to distinguish the correlation in the resulting histogram. Next we plot the scatter plot of the same dataset to demonstrate how different the display of the scatter plot is to the 3D histogram. Let's understand how this code works. So, here we prepare a computer histogram using np.histogram2d, which returns our histogram, i.e. hist and x and y bin edges. Because for the bard3d function we need coordinates in xy space, we need to compute the common matrix coordinates, and for that we use np.meshgrid that combines x and y positional vectors into a 2D space grid matrix. This we can use to plot bars in the xy plane locations. Here, variables dx and dy represent the width of the base of each bar. As we want to make this constant, we give it a 0.1 value for each position in the xy plane. And the value in the z-axis, that is dz, is actually our computer histogram, which is in the variable hist. That represents the count of common x and y samples at a particular bin. Now, the scatter plot displays the 2D axes that also visualize the correlation between two similar distributions, but with a different set of starting parameters. Sometimes 3D gives us more information and better explains what the data is showing. More often, however, 3D visualizations are more confusing than 2D, and it's advisable to think twice before choosing them over 2D. Since we're ready to run the code, let's now move on to our Canopy command prompt. Go to your working directory and run the file. As you run this code, you get this figure as output on your screen. Superb! In this video we've created 3D histograms and learned how to spot correlation between three independent variables. In the next video we'll explore animating with OpenGL.